Welcome to this video. In this video, we are going to study composition series Jordan-Hölder Theorem. Okay, let us define the composition series first. Then we will come to the Jordan-Hölder Theorem. So definition says basically ये जो नाम है वो इस तरीके से जैसे Jordan-Hölder inequality. So we will pronunciate this as Hölder. So definition, and this definition defines composition series. So let G be a group, a chain of subgroups that is G equal to n naught contains n1 contains n2 contains and so on the n such that following some conditions, like the first is each ni is normal in ni minus 1 for I equals to 1, 2 and so on. And second says that जहाँ हमने सॉल्युबल ग्रुप के लिए इसको अबेलियन बताया था, साइक्लिक बताया था, वहीं ये जो सीरीज है वहाँ पर हम इसको सिंपल ग्रुप बोलने वाले. इज सिंपल for I equals to 1, 2 and so on, and this is small n. Okay, and the last one is also similar to the that of soluble, and n is equals to the identity. Okay, if we have this series which follows these three conditions, then we will call that chain as a composition series, is called composition series for G. Now related to the composition series, we are going to define some terminology related to this composition series. Okay, so we will define first composition factor. Composition factors. The factor groups ni over ni minus 1 over ni defined in 2 is called groups are called composition factors determined by the series. Okay, and the next terminology is define the length. So we have length of series. So we define in the above series the number n is called the length of the series. Okay, now if we talk about some important statement and that are useful in the further discussion, let me write that. Okay, so whenever we talk about some kind of simple groups, so suppose n is this is important, okay? Suppose n is normal in G such that G by n is G by n is simple, then n is maximal normal sub subgroup of G. Now what are the maximal normal subgroup? Those normal subgroup of G for which any subgroup that containing n is either n or G only. ठीक है, दैट इज द डेफिनेशन ऑफ मैक्सिमल नॉर्मल सब ग्रुप। तो ये एक स्टेटमेंट हमने याद रखना है कि जब कभी भी किसी नॉर्मल सब ग्रुप के लिए जी बाई एन सिंपल हो जाता है, देन एन बिकम्स द लार्जेस्ट और यू कैन से मैक्सिमल नॉर्मल सब ग्रुप ऑफ जी। ओके, दिस इज द important statement. Now let me write an example. Example says determine composition series for S4. Solution. We have already discussed this in the case of soluble group. So we define n naught equals to S4, n1 equals to A4, n2 equals to the group isomorphic to Z2 cross Z2, Z2 cross Z, n2 isomorphic to this, and n3 is the identity subgroup. Okay, now you can say this is our n naught, n1, n2. This is a 4 order group. Then we have 2 order subgroups, like we define 1, then 1, 2, 3, 4. You can choose any 2 order element here. So we will have the number of such n3 as we have the even permutations of order 2. Then we define n4 as identity. Okay, so if we consider this chain, then you can see that this A4 is normal in S4, this is normal in this 4, this n3 is normal in n2 and n4 is normal in n3, right? ये हमने soluble group जब पढ़ा था तो वहाँ पर भी डिस्कस किया था। Moreover, हमें ये पता है that A4 S4 by A4 that is a subgroup of, that is a group isomorphic to Z2, और Z2 हाँ जो ग्रुप होते हैं वो सिंपल ग्रुप होते हैं। Likewise we have A4 over Z2 cross Z2 type groups, और ये कैसे थे? That was equal to like 1, then we will have 1 2 3 4, 1 3 2 4, then 1 4 2 3। इस तरीके के कोई भी सब ग्रुप से जिसमें एक आइडेंटिटी और बाकी सारे 2 ऑर्डर वाले सब ग्रुप 2 ऑर्डर वाले इवन परमुटेशंस थे। ठीक है, जब हम A4 बाई सॉरी N1 बाई N2 आइडेंटिफाई करेंगे, देन दैट सब ग्रुप विल बी आइसोमॉर्फिक टू Z3, और Z3 वाले सब ग्रुप्स हमेशा तो Z3 दैट मीन्स Z3 के आइसोमॉर्फिक हर एक ग्रुप या फिर 3 ऑर्डर वाला हर ग्रुप सिंपल होता है। Then we have again a group of order 2 and so on. So that means this is series or this chain provide us a composition series for S4.